Hello, and welcome to our training on texturing and bitmapping. My name is Mandy Rosengren. I'm an onboarding engineer here at Anthropology, and I'll be walking through this session today. So in today's session, we'll talk about texturing with bodies, lattices, and fields, but specifically with bodies and fields. So we'll talk about how we can add these bumpy textures, as well as using blocks such as simplex noise 3D and cellular noise 3D to create structures like we see here, such as ones that mimic marble, leather, and wood, as well as mimicking metal AM surfaces using that simplex noise 3D. Then we'll take about a 5-minute break, and we'll talk about bitmapping as well, which can also be used to add textures and create a pattern. So I have this example of using displacement map data from the moon and placing that on a sphere, or adding other types of images that we have, as well as creating a body from an image. So if you have your own logo that you want to create a design for that you can add to your part, we can create a body from that. And some advanced examples like these ones as well, just to show what's possible with our bitmapping. So the first thing, or I guess the second thing we'll talk about after using bodies to create this texture is adding roughness with simplex noise 3D. So simplex noise 3D is a field we can see that is has that scalar field symbol in it, and it's able to create this roughness, this randomness. So you'll take a random seed and a frequency value, and then from there we can add that randomness. So we can see if we change that frequency from 100, 500, 1000, how everything changes. We can also add an amplitude. So the way that we add this simplex noise 3D on a part is we'll start with that sphere, or whatever we want to offset with that texture, that roughness. And then we're going for the distance. We're going to multiply 1 millimeter or that amplitude that we want. So whether it's 0.1, 1 millimeter, 2, for instance. And then we'll have that as our offset of the body. So if we had a no roughness, for instance, we would have that simplex noise multiplied by 0. If you have a lot of roughness, a lot of noise, you can see how that would change from that 0.1 amplitude to 1 millimeter. And I'll talk a little bit more about this in the software as well too. We'll also be using cellular noise 3D, and a lot of the custom blocks that we have in that file use cellular noise 3D. And these are what that field looks like using these different options that we have. So it's going to be infinite, non-dimensional, it's that field, and we'll walk into that. We'll walk through that as well. So let's get started by creating that body. So let me open up a new instance of NTOP, and feel free to follow along with the files that you can download below this video if you were unable to attend this, this training. So the first thing I'll do is I'm going to import my part. So I'll rename this section by double clicking and label this geometry. And I can just label my notebook. I'll just label that texturing and go to my utilities and import a part. So for my part, I have this part for texturing that we'll use. So we have this part. And I'm just going to double click to select this. We'll just use this part, this body. Right click it, and we can create CAD body variable. So now we have this part. And I'll double click and rename this CAD body. And I will also convert it to an implicit body. So under conversions, I'll do implicit body from CAD body. Paste that CAD body in there, like so. And make this a variable, which I will label original body. So now we have our geometry set up. First thing that I'm going to show is just using another implicit body. So whether you have your own design you want to import and place on the surface, maybe a logo, maybe you are just wanting to create a bumpy texture or perforations, same type of process here. So I'll add a new section and I will label this bump surface texture. So we can choose to select this and place this on a certain number of faces. So that's why I'll keep that CAD body visualized. And feel free to choose any number of faces that you want. They just have to be connected and touching. So I'll choose this face and I can hold Control to select a couple options. So maybe I'll choose that one and do this face and that face. So I have all the faces I want selected and they're all connected. I didn't select any edges or vertices, and I will right click and I'll create a CAD face list variable. So I'll just rename this faces. I could have also just had one face, depends on what you want, but by picking on multiple faces, I'll be able to show how we can stitch them together and use our mesh from CAD body to then add our implicit body onto here. So I will search in my search bar for stitch adjacent CAD faces, delete that option, and place in that CAD face. Then for my search bar, I want mesh from CAD body. Place that CAD body in there. And what we can see is that I now have this part that has that meshed surfaces all around. So I'll make this a variable and I'll label this mesh and I'll walk through how to do this bumpy surface texture, but something I'll also point out, and you can go to our training on surface textures using lattices. What we can do is go to our latticing or beta tab, and we have some options such as lattice body from surface Voronoi, lattice body from surface mesh, and we can also use that cell map on CAD face and cell map on quad mesh with the periodic lattice body. If we wanted to add a lattice surface texture, for instance, but I'll save that for our other training and just focus on using our points. But with any of those, it would take in a mesh. So I would use this mesh from CAD body, except for that cell map on CAD face, I would just use one singular face. But I have this mesh, and maybe I want to add these bumps randomly across this surface. So I can use our random points on mesh. The mesh that I'll use is the mesh we just created, and this gives me 100 points on that mesh. I could increase that, I can change that relax and iteration. So if I made this one, for instance, we'll get something that's a bit more random. If we have something higher, we'll have something a bit more uniform, and you can change that random speed. You can also add a spatial weighting. So if I wanted to have a cluster of points in one area, we can do that with the ramp feature. But I have these points where I want to add my bumps and spheres or perforations. And to ensure that it is actually all rested on that body, I'm going to use our closest point block. So our closest point block is really helpful for making sure those points are on the body, but also if we look in our properties, for the closest point, we have this normal. And so the normal will allow us to, will give us that value that's normal to the surface at those points. And so we're going to need that for orienting our part as well. So for our random points on a mesh, I'll choose those points. Our body will be the original body. And so we get points like so on this part. And I'll just add spheres onto here, but we could also add cylinders, implicit body that you imported in, but I'll use our orient object block for that. And I'll make this closest point a variable, so we have that easily accessible, and I'll just label that points. The way our orient object works is we'll have an object, so in this instance, it'll be a sphere. And I'll just have the origin as that center point, that's fine. And we have a radius of 5. I'll make this a bit smaller at 1 millimeter. Our source, that's going to be the plane to let us know how we want to move this sphere to different parts. So we have a source and we have a destination plane. So for these, I both will use a plane from normal. So I'll just place those both in. And let's first think about this source plane. So our source plane is right at that origin. We could specify that by taking the properties of our sphere and the block details and just using that as the center. And then the normal I have pointing up our part. So that's what we're going to match our source plane with our destination plane. Our destination plane right now is that same exact item, but instead of having it like that, I want my closest points and to be that origin. So now if I look and turn those on, wherever I had those original points on that body, now we're going to have these destination planes. So I'm going to match up my source plane with all the planes that we see here. And they're all going to be centered at that origin. However, the normal is always pointing up because we have that 0, 0, 1. And instead, I want this to be placed so it's normal to the surface. With a sphere, it doesn't really matter, but if we were doing a perforation, for instance, we would want that. So with our closest point, we can go into the block details under properties, and we can choose that normal and drag that into the options. So now what we can see is that it is rotated around. If we look at our original body, we can see that all these planes are now oriented on those points, and their normal is normal to that surface. So now if I look at my orient object and turn off everything else, we can see I have those spheres there. And again, if I used a cylinder or a cone, I would have that oriented as I wanted to as well. So if I wanted to have this bumpy texture now, the last thing I would do is first a Boolean union of all of these spheres. So I'll remove this implicit body list because I already have a list of 100 spheres, like so. So now I've gone from 100 spheres to just one implicit body, all of these. And then I'll do a Boolean union. So I'll make this a variable and label this spheres. And then I'll union these spheres to our original body, like so. And I'm viewing this in low resolution, so we can see we have that little rounding. But if we actually wanted that rounding, you can choose that blend radius, for instance. Let me increase my resolution so you can see it a bit better. We can play around with that as well too. So that's one way that we can add texture using implicit bodies. The next thing we'll talk about is that cellular noise 3D and that simplex noise 3D, which we can find in our fields tab next to noise. So I'll make a new section, which I'll label texture roughness. We'll hide this section. Add a new section, which I'll label texture roughness. And noise 3D. So in that fields under noise. Turn off that visibility, and I'll turn off that final visibility of that Boolean union I created. And let's select the simplex noise 3D and type F so we can see what we are looking at. Let's make this 20. And let's increase our frequency to 500. So what we can see is I'm now getting this roughness, this noise. If I made this 100, we can see it's a lot bigger. So we can kind of control what that is with our frequency to change that roughness of our part. So I can make this a variable, and that's labeled frequency. And if I probe my values, what we can see is that this is a unitless value that's going between -1 and +1 roughly. And so what we're going to do is use that offset body block that I showed earlier to offset this part based on our simplex noise 3D. So in the areas that have that offset of -0.5, it's going to have that offset versus offset of 1. So then it'll just stay as the same. So I'll grab that offset body. The body I want to add this roughness is our original body. And because our distance must be in millimeters, I have to multiply this by 1 millimeters to give it units. So if we look at that, we type F, so we'll eventually see this. I'll put my simplex noise 3D as the operand A and 1 millimeter as operand B. And turn off that offset body, because now what we can see is that I have this in millimeters. So we're going to have that range of that offset where we're offsetting inwards versus outwards. And if I close this, we can I originally had. So we're just offsetting it by that simplex noise 3D. We can also change that amplitude by changing how much we're multiplying this by. So if I made this multiply by 0.1, we can see that that roughness is a lot. It's not as large in those certain areas. We've made it a lot smaller. We can make this 5, and we're seeing a lot of noise. So you can play around with that as well. Or maybe you want a varying amplitude as well. So maybe you want some areas to be smoother, some areas to be rougher. So what we can do, I'll rename this the rough part. And the next part that I'll work with will vary that amplitude. So I'll add another offset body. I'll double click on the name and rename this roughness varying amplitude. So I'll place that original body in there. And again, we're going to have to multiply by millimeters to get that simplex noise 3D. Our simplex noise 3D, I'll keep as the same item. So we'll have that frequency of 500, that random seed of 1. But now instead of multiplying it by just one value, I'm going to use a ramp. So for the ramp, I'm just going to use a plane from normal to show where that change is going to occur. And I'm going to place this at the minimum point of this original body. So I'll go into the properties of my original body in my geometry tab under bounding box, and I want to choose that minimum point. So now I have this plane here, and I want this face to be smooth, and eventually it'll become more and more rough as we get farther away from that plane. So I have that in-min Let's make this 0, or maybe we want the change to occur 10 millimeters past our plane up to 75 millimeters. So that's where we're going to have that varying change, and then it'll stop. So our outmin, if we think about, we don't want any offset of the body, we want it entirely smooth, then we'll offset by 0 millimeters starting off and ramp to 1 millimeter with a geometric continuity. So we can see it already ran that for me, where I had that smooth base, and then it becomes rougher. And if I look at that ramp, let's change that viewpoint. There we go. And let's do 0.1 as that contour interval. We can see that we're going to have no offset anywhere in this range until we get to be 10 millimeters away from the plane. Then we're going to increase. So we're going to go from 0.1 all the way to 1 millimeter. So we'll have that full ramping at this, I think we're above that line, or that full noise that we had before. So, and we can kind of see that too, where we're getting that gradual roughness occurring until we have that full roughness that we had before. Like so. And I just typed I because I realized I was also looking at my original body, so it wasn't showing those areas that were going into my part as well too. So this is how we can use that simplex noise 3D to vary that amplitude, create something like this. And one application of this that I'll walk through is how we can mimic metal AM surfaces using the same technique, where we have areas of overhang will have that greater roughness, while areas that are right on top of that build plane, we're going to not see that roughness. So let's turn off that visibility. We can close that entire section, and we'll add a new section, which is mimicking metal AM surfaces. So again, we're going to offset the body, and in the example I have that you can download, I use 2 different offsets. You can combine those 2 as well. So I'll offset body using one type of frequency for that noise and amplitude, and then have another one and combine the 2 to show what this looks like. So first I'll use a simplex noise 3D, which has a frequency of 200. And I'll do an amplitude of 0.4. So I'm going to multiply it by 0.4 millimeters. And I'll make this a variable, which I will label as noise 1. So I have one simplex noise 3D, one type of roughness, and maybe I want to combine it with another one, get that combination. So I'll again follow that same step, where I can multiply it. I'll have my simplex noise 3D as one option. This time I want my frequency to be 500. And I'm going to multiply by 0.2 millimeters. So I'll make this a variable and label this noise 2. And let's see how these differ. So I'll type F so we can see them. So we see those areas that are negative, that are that dark blue to pink, and that's going to be where I'm going into my part, and then adding that noise out of my part. I'll have that light blue color. We can see how it compares with that frequency and that change in amplitude. And let's see what it looks like if I add the 2 together. So I'll add noise 1 and noise 2. And now we get something that's a little bit of both. So that's just kind of showing how we can combine these 2. So I'll make this a variable and label this noise 1 and 2. And if you're working with any type of field that is unitless, you can multiply that, change that frequency, and you can add those together just as we had done here to get a combination of those two fields. So if we want to make this mimic an AM surface, an AM metal surface after printing, what we can do is use a block that's a toolkit labeled angle field. So this one, if you're working with our DBAM, this is also used where we can put in our original body. So let's look at that. Let's look at it from that top view, or sorry, from the front view, like so. And what the angle field does is we have this direction that's going up our part. And if I type F, and let's change that plane from normal to 0, 1, 0. What we can see if I probe my values is I'm getting this angle field. So I can see at where we're at that surface, what the angle will be compared to that direction. So anything here we can see is 180 degrees. We can see how it looks like in that hole as well. So now we're going to get this field based on the angle that this part is from that, that direction, or that direction of your build plate, for instance. So we're going to use this angle field, and we're going to use it to ramp where we're going to have those areas of noise. So I'm going to use it in my ramp, put my angle field now as that scalar field that I'm going to work with. And we can see that I have my in min and in max, where that change is occurring. I have that in degrees. So I want some type of change to start at 0 degrees and then end at 180. For my out min, so where I have that angle of 0, so if you see that would be right above this part, we would expect to have a pretty good surface finish. We wouldn't have that roughness. And so I'm going to have an out min of 0.1. So we'll have a little bit of roughness, but really not too much. And our out max of 1. So when we are at somewhere like here, that we have 180 degrees, we have that big overhang. If this was not printed right on that build plane, we would get that full roughness that we created, that noise 1 and 2. And our continuity will be geometric. Note that our out min and our out max, these are unitless. And the reason for this is because we already multiplied our noise 1 and noise 2 by that 0.4 millimeters and that 0.2 millimeters. So we had that simplex noise 3D that was unitless. Then we added those units. And so I don't want to make this another millimeters, because then we'll get it in millimeters squared. So we can keep this unitless. This is a percentage of a factor of how much of that noise we'll see on our part. So to offset this, so this will be my final body. I have my original body, and my distance, I'm going to multiply my noise 1 and 2 by this ramp. So I'll have that multiplied by that ramp. So this is still going to be in 1 millimeter. And if I look at this part, we can see that at that top surface, I still have a little bit of roughness. I have that 0.1 times that noise 1 and 2. But where we're going to see the most roughness is going to be below this part, as we can see with that overhang of 180 degrees. And I can play around with this. Maybe this is too rough in certain areas for me. But just that gives you a sense of how we can use that angle field, our simplex noise 3D, to get this roughness that mimics that metal AM surface. So I'll label this a variable, and I'll call this final body. So we talked about our lattices a little bit. We talked about using implicit bodies for these textures, and then we used our simplex noise 3D. So staying in that fields range, we can also use our cellular noise 3D. So I'll talk about that next. And I will no longer use this part. I'll just show this with a cellular noise 3D with a box. So I'll close this geometry, add a new section, and I will label this cellular noise 3D. And I'll just add a box to my notebook and type I so that we're just viewing this. I'll select it and type Z so that it is centered in my viewport. And I'm going to make this length 20 by 20 by 50. So I get something like this for our example with the cellular noise 3D. So I'll make this a variable and label this box example. And let's add that cellular noise 3D to our notebook. So under fields, I'll choose that cellular noise 3D. For my frequency, I'll make this 100. And let's turn off these visibilities and just view this with the field viewer. So I'll type F. So this is what we're going to get with our cellular noise 3D. So if we go back to our cellular noise 3D, and feel free to click on these titles in the slides that I've shared with you as a PDF. This will bring you to more information on our support site. I also have some information on procedural texturing in those files. But what this is doing is creating the scalar field gradient from these pseudo-random values using that Worley noise algorithm. So these are the different ones that we can create. So we just are using that cell value that we can see here. You can look and see how these different areas look and play around with how these will affect your design as well too. But let's use that Euclidean and let's just do distance. So we get something like this. So if I wanted to use this to add some type of design, some type of texture to my box, what I can do is same process we did with the simplex noise 3D. So I'm going to use that offset body. For the body, I'll use that box example now. And if I probe my values, you can see that just like the simplex noise 3D, this also has no units attached to it. So I'm going to multiply my cellular noise 3D by 1 millimeter, just to give it those units. And what we can see is that design that we have is now being applied to our box. So you can play around and see how these different algorithms look. That different distance and return type will be on your part, like so. And you can use this to add some types of textures, more than just that roughness. So I wanted to show some examples of that using some of the custom blocks that we already have. And in that procedural texturing PDF, it'll also go through how we created some of those custom blocks, but I won't go into those in detail today. But I'll add a new section and just label this custom block textures. And let's add those in. So if I import my block, in those custom blocks, we have leather, marble, and wood texture. So other three we'll be using in the bitmapping portion of today's session. But let's grab that leather texture. Let's also get the marble and the wood. So I'll delete that input for our part for the leather texture. It already had that CAD body, but I'm just going to use the same box that we had. You can also see that my wood texture already displayed. I had this plate already in place, so I'll delete that. But using our box example that we had, I'll place that box in now for that leather texture and turn off my offset body. So now what we can see is I have this leather texture that is being created using that cellular noise 3D that's in this custom block that we had here. You can change that frequency if you'd like. So we get something like this. We can change that cell depth as well and get kind of a different pattern as well too. So you can play around with this and get something that looks pretty similar to leather. We also have this marble texture as well. So I'll add that box example in and turn off that custom block leather texture. And we get something like this that can resemble marble. And again, you can play around with that weight, frequency, the grooves that we have, and the roughness to get something that you might want to use for your application. We also have something that represents, looks like a wood texture. So I'll drag that box example in there, and we get something like this. And the way that this was created is I have my axis, which is using a cylinder. So we can see that it's all kind of rotated around this. So get that grain of that wood. So I can change this cylinder, I can rotate this around, and you can see that I have that GPU accelerator on, and it's with the real time moving and changing that wood as we're going along. So we can get something like that. We can change that amplitude as well too. We made that 2, for instance. Maybe not what we're looking for, but you can play around with options that make sense for your part. We wanted something like 0.1. We can change that frequency, and you start to get something very, very different as well too. So you can play around with this, see what those ranges are, and we have some more information on these different inputs in our information for those custom blocks. So that's how we get something like this, and just some applications of using that cellular noise and that simplex noise 3D for adding textures to your part. If you have any questions, please let me know. Otherwise, we'll take a 5-minute break as we go to, before we go down to our bitmapping examples. So I'll take a 5-minute break. Feel free to ask any questions as we're going along before we move to the next topic. All right, with no other questions, let's go on to bitmapping. So the first thing that we'll do is just create a 3D texture from bitmapping. And just to give a little bit of information on bitmapping, this is the example that we'll do. So currently this is in beta, but what this feature does, it's a combination of 2 blocks, our import bitmap and our met bitmap to plane. So what we'll do is we can import a bitmap that's going to be a PNG file, that pattern, that image that you'd like to use. And then we'll place that on a plane. So you'll be able to visualize it within NTOP, and then I'll go through the steps that we can do to create a 3D texture from this 2D image, like we can see here on the right. And also, as we're going along, if you want to see some additional resources, we have some advanced texturing videos, as well as this advanced video tutorial on shoes and how they use texturing for that. And for other trainings and recordings of this, you can look here on that link in our PDF. Let's open up another instance of NTOP. Feel free to save what we were working on before, that texturing. Since I already have this file, I'll just not save it, but feel free to save that. And open up a new file that will be used for our 3D texture from bitmap. So feel free to save this with that title, but I'll just name this in my notebook, 3D texture from bitmap. So the first thing that I'll do is input my information, my image. So I'll do image information. And we can find this in our beta tab. We have that map bitmap to plane that we'll use. We also have our import bitmap, which is that utilities exchange. So I'll import that bitmap, which is in our beta, or you can search for it. And for the path, I have some example images that we can use. Feel free to use an example as well that's in that black and white color. You can also use other colors as well, but just feel free to play around with it. Sometimes it works better than others. This is in our beta, so if you have certain features, certain things that you come across when you're working with this, definitely feel free to put that in our feedback form, and you can find that in the contact us at learn.entopology.com in the top right corner. But I'll just use this pattern 3 example, and I'll define a dot pitch of 1 millimeter. So this is optional. Sometimes your part already has the dot pitch defined, but if it does not, you'll need to place a value in there, and you can kind of play around with what might be the best option based on your part for that distance between the dots of the PNG. So I've imported my image, so I'll make this a variable and just label this image. And the next thing I'll do is map this to a plane. So I've placed this in, I've imported it, but I can't visualize it until I've placed it on a plane in my notebook. So I'll place that image as the bitmap. And the plane, I can just do a plane from normal or a plane. Let's zoom out. I can select it and type Z. Because if we look at our imported bitmap under properties, we can see how large this is. And this image actually is quite large. So that's why I really had to zoom out. But maybe you don't want it to be this large. You don't need something that is 900,000 millimeters. So what we can do instead is define our length and width here. So I'll make the length as 12 millimeters and the width of 15. So now if I select it and type Z, you get something like this. I could really kind of warp my image as well by changing that length and width. So what you're working with, just make sure that you have those proportions that you want. But this is fine for me. I have this black and white image, and I have that bitmap plane. If I go into the block details for this bitmap plane, I have different scalar field options. So what all of these are is taking this image and we're creating a field out of it. So just as we had done that offset of the body with the simplex noise, we can offset the body using one of these fields. And depending on what type of image you're using, you might want to use hue, green, red, blue, or grayscale, for instance. And since this is just a black and white image, we can use that grayscale. But I'll use it, so I'll just make this a variable, just so we have this easily accessible. You could also play around and change this option. But I'll rename this grayscale values. So I have everything that I need for my image information. I imported my bitmap, put it on a plane, and now I have this grayscale values. And if I turn off the visibility of this and type F to view this grayscale values, what we can see is now I have this field. It's going to be only positive where we have that color. We're going to have that 1, that black, and then you can see how it changes. And anywhere outside of that image, it's just going to kind of follow where that image was black or white, and you get that with that black to light blue as we're going from 1 to 0. And we can see it's a little bit rough as well too in certain areas. So you might want to play around with that image ahead of time as well too to best prepare it for bringing this in. But this is going to be fine for the purposes that we're working with. So what I want to do is add, just like I showed in that image in my slide, add this design to just the top surface of a box, for instance. So for the box that I want to do, I'll add a new section and label this adding bitmap to design. And I'll go to my create tab and choose a box. For my length and width, I'll do 10 millimeters and my height will be 2.5 millimeters. So I get something like this. I'll make this a variable, just label that box so I have it easily accessible. And just as we had done with the simplex noise 3D, I'm going to offset this body. So I'm going to offset the body here, but what I'm going to do is instead of just offsetting it by 1 multiplied by the grayscale values, I'm going to do is I'm going to ramp it. So I have a bit more control over how high off my part it is. So my box is what I'm going to offset, and I'm going to use a ramp for this distance, where the scalar field is that grayscale values. And if we go back to that field, I always like to look at the field that I have for that ramp. And if we go through these, you can see that they range from 0 to 1. So our in min would be 0, out min, or in max would be 1. And where I have those values that are 0, so that bright blue, I'm going to have no offset. So that'll be 0 millimeter offset. And I want it to be offsetted up 2 millimeters with a continuity that is geometric. So now what I can see is it's done it throughout my entire part, but it has offset it by that millimeters that I wanted, but it offset it throughout this entire part. So what I can also do is trim this so that I only have a small region of this that actually has this texture I want, instead of this entire box being affected by it. So then I'll do my trimming box. So I'll label this block our 3D texture. And then I'll make a trimming box. So I'll add a box to my notebook. And I'll make this center at 1.5 with a length of 5 millimeters, width of 10, and a height of 1. So if I look at this part in relation to my box, you can see that it's going slightly into this part. And this is going to be where I want my texture to actually be. So now what I'll do is Boolean intersect our 3D texture with this box, so that I'll only have that texture. So that box is the first option, our 3D texture is the second, and we get something like this. So now to add it to my original part, just so I have that texture included, what I'll do is a Boolean union. Of that intersected part, I'll label this top texture and that original box we started with. So now I have something like this. You can see it's still rough at certain areas, and this still is in beta, but like I said, you can use software such as ImageMagick if you wanted to edit that bitmap a little bit, have that image so that it is a bit smoother when you are running your bitmapping. But this is showing kind of that example of one way that we can add that texture. And I have that also in our example file, so feel free to take a look at that as well. So now I'll make this a variable and label this box with texture. So I have this box with a texture. Another neat feature that we can do with our bitmapping is if you have a logo image, what you can do is take that image and use that and create an implicit body from there. So if I look at my, for instance, if I go to my custom blocks I have, one of the ones I have is this custom block, which is CB implicit body from logo. So I'll open that up so we can see what that does. And what this does is it takes in a PNG file. We can see that it's going to map our end top logo to the plane. There's some other areas that we have too that are using some length and width defined as this input. We won't go too much into detail, but you can also choose if you want a grayscale, red, blue, green, alpha, or hue, and it goes through a similar process that we went through to then create the end top logo. So I won't go through that file specifically, but feel free to use that, add your own image. but I will add it to this block so we can see what that looks like. So I'll add a new section called adding logo, custom block. And I'll import a block now into my notebook, which is in our custom blocks that I have in the files for today's session. And it's that CD implicit body from logo. So if I look at this, it already did it for me because I already had my logo in that path. But feel free to try your own logo, see how that works by just placing that in that image. And just as we saw before, this doesn't have to be a black and white image. It can be a color image. You can see how it looks with the red. If you want to see that blue scale, see what might work better. The gray scale, especially if you have that black and white image, it works pretty well. And you can again change that length and width. So if I wanted this to be a bit smaller, I'll make this 2. You can see it squished it a little bit by 2. And I'll make that depth 0.5. Like so. So I have this logo, and then I'm just going to add it to the part using that orient object that we had before. So I have my orient object, and the object I want to orient is this logo. So I'll rename this by double clicking on that title as logo. For the source, I'm going to use the plane from normal. Let's see what the starting one looks like. And I'm going to change that origin just so that it is, I want my part to be, I want this to be at the centroid of my part. So I can go into those properties for my logo in the bounding box. And I'll choose that centroid for our origin. Like so. And for the destination, where do I want to place this? What I'll do is also use that closest point just to show another example of it. It can be really nice to, kind of around the vicinity of where you want your part to be, but not exactly aligned. You have trouble aligning it right to that body. So we can use a plane from normal again, where the origin, we'll use the closest point so that it's definitely on our body. We'll place this on our box with texture. And for our point, I can just drag and move this. So I don't even have to have it exactly on my body. I can just move this around, see what might be a rough location. And we can see it's already placed on there as soon as I went through this, because our closest point placed that point that we started off with, that we can see is above our surface. It placed it right onto that surface. If we look at that plane from normal, which we don't have to change that normal since this is a flat surface, we have that pointing up, and it just oriented our logo from where it was originally to that location. So now we have this logo where we want it to go. The last step that we would do is then union these all together. So I'll make this a variable and label this logo on part, and then a Boolean union of that box with texture and that logo on part to then get our final body. And I can rotate this, or I can change that blend radius if I wanted to as well. So you can play around with those options also. So you might want to smooth things out. This isn't perfect either. So you might want to play around with some of these options, some of those inputs, but just to show an example of how we can add that design using that bitmapping. So we have that image, placing it on there, as well as taking the logo and adding it to our part. So I definitely recommend trying this with your own logo, your own patterns, and seeing how that looks. So that pretty much covers everything we'll go through from scratch on adding bitmapping and adding these textures. But the last thing I wanted to go over was just showing kind of, okay, we know this, what are we going to do next? What can we do to kind of go further with this design? So I always like to end with just a cool advanced example as well. And so I have that labeled as our advanced bitmapping example. And all we have is this custom block that I have here and in your custom blocks, CB warp image to shape. So what this does is just to show some of the capabilities we have is it'll take a starting shape, a box, a cylinder, or a sphere, and you can try to warp a design using a planar warping and apply that onto the box, cylinder, or sphere, a cylindrical warp or spherical warp using an image provided. So let's start with that same image we just used. So I'll take that pattern 3 and it'll run through this custom block and let's see what that looks like. So now what we can see, it gave us pretty much that same design we had before where it's offsetting our body and we're getting this planar design. What we can also do is do a cylindrical wrap or warp and a spherical warp. So let's see what those both look like. So now we can see that same design that we had is now being warped around the center. So if we look at this top and bottom, it looks the same exact thing. On the side, it's just those side areas that you have warping. So if you wanted to warp your design so it's centered around that part like so, like a cylinder, we can use some fields that you can learn more about in our intermediate and advanced field-driven design trainings. And then if we wanted to do a spherical warp, and so we can see that it took that image and it's wrapped it now entirely around this part. So now we're going to get this design all around this box. We can see here, and you'll get the same result with that sphere or that cylinder. So if you are creating some type of stamp, for instance, with a certain design, you can use that spherical warp on the cylinder. So let's try that with a different example. I'll choose like these patterns and let's do a cylinder that we're going to add the shape. So maybe I wanted to make something that I roll across a certain part to add that stamp, that design to. We can see I can get something like this, where we get this really neat shape from part. Let's look at that image again that we had, which is this design here. So it took this type of design and we can see we get that same thing on the side, but now on the top and the bottom, we get this cool design from the spherical warping that we can then use in any of our designs. And let's see what that looks like with cylindrical warp as well too. Maybe actually let's try a different pattern. Let's try leaves and see how that looks. You can feel free, I have a couple of different patterns that you can play around with. You can take something from online and choose that as well too, as any of your patterns to play around with. So sometimes that cylindrical warp, you can see it's just going to wrap it around. You can see those leaves warping in, but we can also see that with a sphere. The spherical warp if we wanted that. So now we're going to get these leaves that have been spherically warped around this part, or that box. So you can really play around with this and see how those different images look, how that different warping might go, and hopefully this kind of launches some cool designs that you're interested in and looking at. But the last thing that I wanted to show too, so we also have along with these, let's go back to that planar warp so we can see that. What we have also in these examples, I have a displacement image, a displacement map of the surface of the moon. And just took this from NASA's website. And what we can do is we can warp this using that spherical warp onto a sphere and get this design on our sphere. So we can see that's our leaves that we had before. And I'm just going to add that moon PNG. Let's choose that sphere and let's do spherical warp. And let's take off this dot pitch. This already came with the dot pitch. And so what we see is we now have the surface texture of the moon on the sphere. So just kind of a fun application to show and some advanced bitmapping examples. So hopefully this gave you some clarification on how to add those texturing, how to add that bitmapping. And any other questions, I'll stick around. If not, thank you for coming to our live training, and definitely feel free to check out the other ones that we have either recorded or as our live sessions as well.